Hello. Hello.
Everyone kindly rise as the dignitaries have arrived. I would request conveners of the conference to escort the dignitaries to the dais. Thank you, everyone. Kindly take your seats. Creativity is a spark. It can be excruciating when we are rubbing two rocks together and getting nothing. And it can be intensely satisfying when the flame catches and a new idea sweeps around the world, said John Lehrer. For few ideas to sweep the world, people have to come together and talk about them, listen and participate. A very good morning to all. I, Dr. Sumana V.S., will be your master of ceremony for today. I welcome everyone to the inaugural function of International Conference on Recent Research in Applied Science, ICRRAS-2023, organized by the Departments of Basic Science and Srinivas Institute of Technology, Valachil. Prayer is an attempt to merge the inner workings of our life with the rhythm of the universe. When we pray in such a way, all the workings of the universe will function to protect us and the endless cycle of the painful reality will be transferred into a cycle of victory and happiness. Prayer is the key to open the door of a door to unleash that infinite human potential within our lives. Now, I request Ms. Diksha Sharma, first year CSE, to lead us in a word of prayer.
सिन्धूरवदना कोडुवर सिन्धूरवदना सिन्धूरवदना कोडुवर सिन्धूरवदना ಇಂದುಧರಾತ್ಮಜ ವಂದಿಸುವೆನುನಾ ಇಂದುಧರಾತ್ಮಜ ವಂದಿಸುವೆನುನಾ ಸಿಂಧೂರವದನಾ ಕೊಡುವರ ಸಿಂಧೂರವದನಾ ಭಜಕರ ಮನೋರಥ ಪೂರಕಾ ಸುಜನರ ಭವಾಂಬುದಿ ತಾರಕಾ ಭಜಕರ ಮನೋರಥ ಪೂರಕಾ ಸುಜನರ ಭವಾಂಬುದಿ ತಾರಕಾ ವಿಜಯ ಸಾರಥಿಯ ಭಜನೆಯ ಮಾಡಿಸು ರಿಚಿನ ವರಿಧಿ ಕುಂಭವ ಸಂಭವ ಸಿಂಧೂರವದನಾ ಕೊಡುವರ ಸಿಂಧೂರವದನಾ ಇಂದುಧರಾತ್ಮಜ ವಂದಿಸುವೆನುನಾ ಇಂದುಧರಾತ್ಮಜ ವಂದಿಸುವೆನುನಾ ಸಿಂಧೂರವದನಾ ಕೊಡುವರ ಸಿಂಧೂರ ಸಿಂಧೂರ ಸಿಂಧೂರವದನಾ.
Thank you, Ms. Diksha. Small cheer and great welcome makes a merry feast, says English dramatist William Shakespeare. I now request Dr. Chandrasekhar KG, Professor, Department of Chemistry, Srinivas Institute of Technology, and the coordinator of ICRRAS-2023 to welcome the gathering.
A very heartily good morning to everyone joining us today. Respected dignitaries on the dais and august gathering of the dais. It's my pleasure to stand before you to welcome you all to this two-day international conference. In today's digitally transformed world, scientific inventions and technological innovations are striding forward. The academic institution also transformed and getting into research activities along with the teaching in almost all education institutes. So we felt that if we offer a national or international forum to present and discuss academicians' research outcomes in presence of eminent researchers would be an excellent opportunity to share and exchange our research thoughts and hence their early realization. The conference is intended in bringing out innovative ideas of academicians in science, research scholars, and students shall disseminate their original thoughts and research to promote research and development activities. It also focuses on networking people with similar interests to have a collaborative work and to have better solution for societal problems. This is our second step in organizing conference after successful completion of an international conference in the year 2022 by online mode. This time we moving forward ahead to hybrid mode. First and foremost, I would like to submit sincere gratitude to our management, President of A. Shamrao Foundation, Dr. A. Raghavendra Rao, who is also the Chancellor of Srinivas University, and Vice President of Shamrao Foundation, Dr. Srinivas Rao, who is also the Pro-Chancellor of Srinivas University, on their absence. They could not able to join us today due to some unexpected, inevitable reasons. Today we have with us Dr. Mahesh M.G., Associate Professor in Physics, Manipal Institute of Technology, Manipal, to inaugurate the conference and to address us on behalf of Srinivas Institute of Technology and Organizing Committee, wholeheartedly welcoming you, sir. Whenever we present any new thoughts of activity in the college, our beloved principal, Dr. Srinivas Maya D, encouraging us, and he is the guideline for us at each and every stage. He is with us today to preside over the function and to address us, wholeheartedly welcoming you, sir. I would like to warmly welcome the guest speaker joined us today by online, Dr. Reza Sharafuddin, Associate Professor, Department of Mathematics, Faculty of Intelligent System, Engineering and Data Science, Persian Gulf University, Iran, who have generously agreed to share their expertise as a keynote address on mathematical chemistry, spectral graph invariants later today. Welcome you, sir. I extend heartily welcome to Dr. Suryanarayana K, HOD of Physics, Dr. Gopal Krishna Bhatt, N, HOD of Chemistry, Dr. Anant Kumar Kulkarni, HOD of Mathematics, who are the conveners of this conference, guiding us throughout. I welcome all participants and delegates, those who are responded to our call by sending the research paper to present during the conference and joined us now. Many of them had to join and some of them joining by online. Well, I welcome all of them. I welcome all the HODs of various department and faculty colleagues joining us now. I welcome my dear students. Some of them showed interest and present here now for this program. Let us have a very productive conference with exciting and encouraging discussion and exchange of knowledge so that together we can anticipate a future of breaking through knowledge, research and technology for humanity. Thank you, one and all.
Thank you, sir, for that wonderful welcome. A flower cannot bloom without sunshine. A man cannot live without love, says Max Muller. And to show our love, I request Dr. Srinivasa Mayadi, Principal, Srinivas Institute of Technology, Mangaluru, to florally welcome the chief guest of today's inaugural function, Dr. Mahesha Yamji, Associate Professor, Department of Physics, Manipal Institute of Technology, Mahe, Manipal. Thank you, sir. I now request Dr. Anant Kumar Kulkarni, Professor and Head, Department of Mathematics, Srinivas Institute of Technology, to florally welcome the President of today's inaugural function, Dr. Srinivasa Mayadi, Principal, Srinivas Institute of Technology, Mangaluru. Thank you, sir. Once again, I welcome Dr. Reza Sharafuddin, Associate Professor, Department of Mathematics, Faculty Intelligent Systems, Engineering and Data Science, Persian Gulf University, Bushehr, Iran. I welcome you, sir. Travel light, live light, spread light, be the light, says the Sikh Guru and Yoga Guru Harbhajan Singh Khalsa. I request all the dignitaries to inaugurate this international conference on recent research in applied science by lighting the lamp. Students on basic business and applied science are lighting the lab.
शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः शत्रुबुद्धिविनाशाय दीपज्योतिर्नमोऽस्तु ते दीपज्योतिर्नमोऽस्तु ते दीपज्योतिर्
I also request any two external participants to come forward for lighting the lamp.
स्वच्छामि मे सदा रविरस्तं समारभ्य यावत् सूर्योदयो भवेत् रविरस्तं समारभ्य यावत् सूर्योदयो भवेत् यस्य तिष्ठेत् गृहे दीपः तस्य नास्ति दरिद्रता शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः.
Thank you, sirs and madam. I request Professor Sahana GK, Department of Physics, Srinivas Institute of Technology, Mangaluru, to introduce the chief guest of today's inaugural function, Dr. Mahesha MG, Associate Professor, Department of Physics, Manipal Institute of Technology, Mahe, Manipal.
Respected dignitaries on the dais, I'm very glad to introduce today's chief guest, Dr. Mahesha MG. He is currently working as Associate Professor in the Department of Physics, Manipal Institute of Technology, Mahe, Manipal. He completed his graduation from Vivekananda College, Puttur, and post-graduation in physics from Mangalore University. In the year 2009, he received his PhD from National Institute of Technology, Surathkal. He has got 20 years of teaching experience. His area of interest is growth and characterization of nanocrystalline thin films for device applications like solar cells, photosensors, TFCs, and memory devices. His area of expertise is thin film device fabrication via physical and chemical route, IV analysis of 2 and 3 terminal devices. His area of research are growth and characterization of nanocrystalline thin films for device applications like solar cells, photosensors, TFCs, and memory devices, 1 to 6 compound semiconductors for optoelectronic applications. In the year 2005, the prestigious C.V. Raman Award was won by our today's chief guest. In his credit, 4 research projects with total grant of about 65 lakhs. He published more than 75 research papers in national and international journals. He guided 2 students for PhD, and presently 5 students are pursuing PhD under his guidance. We are very happy to have you as the chief guest of today's function. Welcome you, sir. Thank you, one and all.
Thank you, madam. I request the chief guest of today's inaugural function, Dr. Mahesha MG, to address the gathering.
President of today's function, Dr. Maya sir, conveners of this conference, Special Mention, Dr. Noor Surinan sir, my teacher in Vivekananda College, Puttur, and conveners from the Department of Chemistry and Mathematics, and the dignitaries, participants, and friends. Very good morning to all of you. I first congratulate the Basic Science Department for organizing this international conference. I know the difficulties or challenges that we face while organizing such events and the effort required to do that. So once again, I congratulate the departments for organizing this event. The conference is actually the venue or the place where we can interact each other, discuss and exchange our ideas. So I don't want to make a long speech here. This is meant for scientific deliberation or discussion or debate. So that should happen. And as a custom, I want to make a I want to tell a few words from my position. I am reminded of Sir Isaac Newton's words. He said, "If I can see further, it is because I am standing on the shoulders of others." That says what is the importance of exchanging our knowledge or transferring our knowledge through which we can do the advancement or we can achieve new heights in science or technology. When it comes to showing our research to the peers, there are two ways. One is publish your articles in journal papers. Another is make presentation in the conference of this kind. Publication and conference both have their own advantages. So when it comes to conference, I feel that it has some advantages which the paper publication won't give. Here you can discuss with your peers, then you can exchange your ideas, we can discuss your problem, then how we can solve that. So the teamwork, collaboration, all these things can happen through the conference. So that way, presenting paper in the conference will help us to gain and move forward in our research. Then when it comes to the research, what is the ultimate goal? The ultimate goal of research is bringing our living standard up. So when it comes to that, the Sustainable Development Goals, some 17 SDGs were set. One of them is affordable and clean energy. So everyone should get the per capita consumption. That is the one of the parameter that will measure the living standard, and per capita consumption of any country that will tell where we are standing. And compared to the so-called developed countries, we are much lagging. The only way in which we can achieve that is production of renewable energy. So the emphasis is given on renewable energy. So when it is a renewable energy, the maybe either solar cell or thermoelectrics, these are the ways in which we can produce. And the production, that is the energy production and the storage. These are waiting for some breakthroughs in material science. So I am sure that this conference will give some space for discussion on these topics as well. And this is the conference where all the experts from chemistry, physics, and mathematics are joining. So I'm confident that this is the place, or this is the which is a kind of catalyst which can foster the interdisciplinary research. So people from various disciplines. So when it comes to material science research, we need chemistry, we need physics, then mathematics if you want to model, because in these days what we do is, instead of going by experiment alone, we can simulate the systems, various new synthesized materials, so how it can perform. We can predict what is the effect or what is the device suitability, what is the efficiency that we can expect using those materials with the various models. So mathematics is inevitable, any research you consider. So I believe that this is the ideal place for fostering the interdisciplinary research. I don't have much to say. We are waiting for some scientific discussions and deliberations. So I wish this conference a great success. Thank you, and thank you for the opportunity.
Thank you, sir. I request the president of today's function, Dr. Srinivasa Mayadi, Principal, Srinivas Institute of Technology, Mangaluru, to address the gathering.
Good morning to all of you. Good morning. Respected chief guest of today's function, Dr. Mahesh, Dr. Surya, coordinator of the program, Dr. Surya Narayan, Dr. Gopal Krishna, Dr. Anand Kulkarni, my colleagues and dear participants. This is the second international conference is organized by the Basic Science Department. Earlier we had first conference that was really successful. It's on the online mode. Now it is advanced to be made. It's advanced to the hybrid mode, online and offline. Both we made it. Our chief guest is already briefed to you. Why we require this type of conferences? There is a lot of research works going on in the various fields. The research work will become successful if it be discussed or deliberated and get the different opinions, different ideas from all the people. Then how to make that was successful? Then the research is going to be successful. If we only one person does the work, if it is not deliberated or it is not published or it is not presented to the others, that research may be restricted to few areas only, with his knowledge only. It may not be exposed to the others' knowledge. So whatever the development is going to happen in the research field, it should be discussed in all the steps, so that this type of conferences helping the research people to come and present their research papers, so that there may be discussions and also they are exposed to the others' research areas. That is the reasons all the people are arranging the international conference on research topics. Now coming to the applied science, recent research and applied sciences. So I hope our chief guest is already briefed you. To make the life easier, the advancement in the science should happen. As many of you are also aware of that, engineering is the extension of science. How to make application by using the science in human life, that is the engineering. So what is the developments happening in the science? I hope all of you are aware of that. The recent one may be a Chandrayana or Suryana, whatever it may be. It's happened earlier 2-3 years back. It was failed. Within 2.5 years, people have done a lot of research work and they are so confident that this time we are going to be successful. Before the Chandrayana, they are starting itself. That is the reasons they give a lot of good publicity as well as the online transmissions, so that throughout the world people can able to see. Maybe as I hope you also may be seen that launching and last moment of the Chandrayana will be landing that in the moon. Maximum viewers throughout the world seen on that event in the live transmissions. It may be YouTube or maybe some other ways. So this is what is going to be happens. Lot of research work is going to be happens. Lot of areas will be there, but it is to be exposed, or it should be done the research and how best we can make use for our life becomes easier. That's we have to work. Maybe this conference we are combined 3 areas, that is mathematics, physics and chemistry. So all these 3 is to be required almost in all the research areas. You say that computer science fields, or whatever we say, artificial intelligence or data science, whatever we talk now, it may be related to the mathematics. Okay, regarding to the materials, if we talk, it may be physics and chemistry. We were thinking for the nanomaterials, nano things. We want everything will be a smaller sizes. Okay, I hope you maybe agree for this. When the mobile was launched, or now the mobile does almost all. See that the size of the desktop come to our mobile size. Maybe in the future it may be one sheet of paper, small sheet of paper, okay, having maybe a less thickness, maybe 1 mm or less thickness. Okay, you can fold and put it in your jib. The mobiles like that, it will do all type of works for you. Okay, that the development is happening in the mobile field. Okay, now carrying may be difficult, you have to handle and all. That will be, you can able to fold and put it in your jib, and you can able to go very easily all the places. So that type of materials is to be developed. Research is going on. Maybe like as electrical cars, battery. People talks now about that, maybe it's emission free, everything we talks. Yes, but the battery development, where the battery production is happened, there is the emission is very high. Example at present, the technology is improving it, they have started reducing it, ultimately it should be get reduced, and how to expose the battery after its life. That's also to be the question will be there. So a lot of research work will be there in the coming days. Lot of areas, it may be I just had 1 or 2 points, but if you go to the science field, you come to know that lot of areas still is not touched areas. So this type of conference, people, research people come together and discuss the things, automatically the new ideas feed to the people, so they can able to publish their papers and they can present their papers, and ultimately they can do their research work, PhD and patent, etc., etc. So with this, I'm very grateful, Dr. Mahesh. He has traveled from morning from Manipal to here, and he is on the time for inaugurations of this 2 days conference. We are very grateful to you, sir. I should not forget the organizing committee who are organized this event. From last 2 months, they are running here and there and organized this event. I hope this event is going to be successful. That will be tomorrow. We can judge how many papers are published, how many participants are there. All that will leads to the success of our conferences. I request each one of you actually participate and discuss, raise the questions, get the answers, and carry forward and improve your research thinking and research work in the further days. Don't leave it after just the presentations of the paper or to the topics, whatever that, but think on that. Further you have to develop, ultimately that leads to your success. With this, I wish each one of you a happy day, and let we have very great success of our 2 days national conference. Thank you.
Thank you, sir, for your wonderful words. Social scientists have found that the fastest way of feel happiness is to practice gratitude. Now I request Professor Amita H., Department of Physics, Srinivas Institute of Technology, Mangaluru, and one of the coordinator of today's conference, to propose the vote of thanks.
Good morning, everyone. Respected dignitaries on and off the dais. I'm happy to deliver vote of thanks on the occasion of International Conference on Recent Research in Applied Science 2023. First and foremost, on behalf of the principal, staff and students, I extend my wholehearted thanks to Sri C.A. Raghavendra Rao, Chancellor, Srinivasa University, President, A. Shamarao Foundation, who is our continuous source of inspiration. Also, I extend my sincere thanks to Dr. A. Srinivasa Rao, Pro-Chancellor, Srinivasa University, and Vice President, A. Shamarao Foundation. I would like to express my deep sense of appreciation to the President of today's function, Dr. Srinivasa Mayadi, our beloved principal, who is our continuous source of inspiration. On behalf of all gathered here, I extend my wholehearted thanks to you, sir. It gives me an immense pleasure to express my gratitude to Dr. Mahesha MG, Associate Professor, Department of Physics, MIT, Mahe, Manipal, Chief Guest of today's conference of today's function, for his gracious presence on this auspicious occasion. On behalf of the management, staff, and all gathered here, I submit my sincere thanks to you, sir. I thank keynote speaker of today's inaugural function, Dr. Reza Sharafuddin, Associate Professor, Department of Mathematics, Faculty, Intelligent System, Engineering and Data Science, Persian Gulf University, Iran. Thank you, sir. And he is going to address the keynote speech soon after this function. I also thank the conveners of this conference, Dr. Gopalakrishna Bhatt, Head of Department Chemistry, Dr. Suryanarayana K, Head Department of Physics, and Dr. Ananta Kumar Kulakarni, Head Department of Mathematics, for organizing this program in a great way. I would like to express my deep sense of thanks to all the participants who are going to participate offline and online in this two-day international conference. Finally, I acknowledge the gracious presence of all the HODs of various departments, coordinators of this event, faculty members of the Basic Science Department and the branches, and other departments and students on this occasion. Thank you, one and all.
Thank you, madam. With this, we have come to an end of this inaugural function, and I request conveners of the conference to escort the dignitaries of the dais. Thank you, everyone. Here I request our keynote speaker, Dr. Mahesha MG, Associate Professor, Department of Physics, Manipal Institute of Technology, Mahe, Manipal, to enlighten us with his keynote address. Over to you, sir.
Okay. Today I want to present a small piece of work that is carried out by my PhD student. Today's title is Unlocking the Potential, Exploring the Defect Tunability and its Impact on the Properties of Copper Oxide Thin Films. Before I start my talk, I would like to tell about my institute. I am working in Manipal Institute of Technology, and which is coming under Manipal Academy of Higher Education. It offers various courses, including PhD, and we are having TMA Fellowship, which is at par with the any UGC fellowship, and we are calling twice in a year. One is in December, another is in June. So those who are interested in PhD can apply. There will be entrance exam, then followed by interview. Okay, this is the outline of my today's talk. Then before I start, I would like to tell about my lab. This lab is established through KFIST grant and also BRNS and UGCDI grants. So we have successfully completed 4 projects, and all the facilities were established through these grants. And 3 students have already completed PhD from this lab, and 3 are pursuing. And today's talk is a piece of work carried out by Ms. Aditya Prakash as part of her PhD project. Okay, if you see the title, mentioned that as a defect. So defect is a negative word actually. Its meaning is imperfection. So always we need a perfect system, or we move towards the perfect. But here, when it comes to semiconductor, the defect is a tool which can be used to tailor the properties. So we deliberately introduce defects. Normally we talk about perfect or ideal system, but here we deliberately introduce some imperfections or defects through which we can tune the properties according to our requirement. And when I say defect here, to the younger students, we are talking about the defects present in the crystal structure. So you already studied what is crystal. It's a regular arrangement of atoms in the lattice. And defect means it's a deviation from its ideal property. So there can be multiple ways, or there can be multiple defects. Foreign impurity is a defect, or dislocation from the normal position is a defect, or interstitial is a defect, that is which is not supposed to be the position of the atom, that is a defect, or the vacancy, some seat which is not filled is a kind of defect, or that seat is filled by some other atom, that is called anti-site, that is also a kind of defects. So there are various types of defects possible in the crystal, and we can't have an ideal crystal when you grow it. Sometimes these defects are intrinsic, but what I talk today here is deliberately introduced defect to enhance this property. The material that we work on is copper oxide, which is known for multiple applications. This copper oxide, it's a P-type semiconductor. It has a monoclinic structure, and its band gap is somewhere between 1.3 to 2.1. It depends on the process that we use to fabricate it. And 1.3 to 1.5, when that any semiconductor which has band gap around 1.5 is ideal for photovoltaic application. So solar cell application, it is of course, it has other applications as well. So photovoltaic or other applications like batteries and all, this material can be used. So these are the applications. So as I mentioned, one is a solar cell because of its direct band gap, and it's a band gap value which suits with the solar radiation. The reason why 1.5 is it matches with the solar radiation. The maximum energy comes somewhere in around that range. So if you see the solar spectra, you can just Google solar spectra and how the pattern is. There the maximum energy lies somewhere in that range. So it can be used to harvest the maximum fraction. Then other applications, it can be used as a gas sensor. It is sensible to ammonia and then carbon monoxide and all. Then batteries, it can be used as an electrode. Then other applications, in it can be a superconductor, provided you dope it with suitable dopant. Lanthanum doped copper oxide is one of the high TC superconductors. Then water splitting. So these are some applications of copper oxide, and our work is mainly focused on solar cell. So when I say it is ideal, it is not again perfect. Its optical properties are ideally suitable for solar cell application, but its electrical property is not that supportive because copper oxide is highly resistive. You know how the solar cell works? It's basically a PN junction. And if you have the high resistive material to form the junction, then the series resistance will be more, then the output that we can draw will be going down. So along with the optical property, we have to tune its electrical property as well. So here we try to enhance its electrical conductivity by deliberately introducing some defects in the crystal. When we are introducing the defects, we have to move it from the normal. So the easiest way is doping. These are some suitable dopants, and we have chosen zinc as the dopant for some reason. Actually, zinc and copper, they have same valency. Still, we use it as a dopant. Normally, we use the dopant as one which is having valency, one less or one high, depending on whether we want P-type or N-type. But here we have used zinc as dopant, which is having same valency as silicon, because our purpose is introducing oxygen interstitial, and to attract oxygen, we are using zinc, and zinc is not contributing to enhancement in the electrical conductivity. And another reason is its ionic radii. It is about 0.74 angstrom, whereas copper is 0.72 angstrom. So the difference between the ionic radii of these two are very less. If it is very less, then the lattice distortion will be minimal, and we can introduce that with minimum distortion in the crystal structure. And the third, that is what zinc has higher reaction rate, and thereby it has a strong affinity for oxygen compared to copper. So our aim is to to bring oxygen as an interstitial in the system. Interstitial means it is the position which is not normally occupied by the atom. So we are introducing the interstitial, and to introduce, you can expand the lattice, or you can process it in oxygen-rich condition, or you can do isovalent doping, where the dopant has the affinity, or it will lower the hopping barrier, so that it can make an easy path for the oxygen to enter the lattice. So for these reasons, we have chosen zinc as the dopant. And this is the experimental procedure that we have followed. We have followed spray pyrolysis technique. The name itself indicates what is the method. We are spraying the solution, and pyrolysis is happening, and we are taking the precursor solution, and its aerosol is created. Then that aerosol is falling on the hot substrate. Then thermal decomposition that will lead to the formation of the required compound and some byproducts. In case of, suppose I want copper oxide, I can take copper chloride as the precursor, and when it is happening in the air ambient, the oxygen is already there, so it will form copper oxide with some byproduct as HCl, so that will get evaporated. So this is how the experimental system is. And initially we try to optimize the copper oxide formation. Then after confirming that copper oxide is formed, we went out for doping, and we doped with zinc for various concentrations. And I think I can skip the optimization part. I will go what is the effect of zinc and how the zinc has changed the properties that I will discuss. Okay, we have tried at various substrate temperatures. When it comes to this spray pyrolysis technique, pyrolysis as the thermal decomposition, so temperature is a parameter that has to be tuned to in order to get the good quality thin film of semiconductor. And another is the doping, the precursor concentration. That concentration will decide what should be the growth rate, and the growth rate will decide the degree of cristalinity and so on. So we have tried with the different substrate temperatures, and this 623 and 673. That is, these two were found to be favorable, where we obtained copper oxide. Then to tune it further, we went on changing the concentration. Then we finally concluded that the lower substrate temperature, that is where it gives copper oxide and the temperature is relatively low, that is better. And these are how the optical property and is changing. I have to finish by 11, right? Okay, so I will then, this is just an optimization part, so I can skip that. So this is what the result that we got. The last one, that right side graph, it shows how the resistivity is depending on substrate temperature and the concentration. So as I mentioned, lower substrate temperature and higher concentration is leading to the lower resistivity. That is what desired. And so we have chosen 623 as the deposition temperature and 0.15 molar concentration. Then this is what the main topic that I wanted to discuss. So once we finalized the deposition parameters, we have introduced zinc as the dopant. So when zinc is added as the dopant, you can see the various zinc concentrations, how the XRD pattern is shifting. So the peak is shifting towards the left. It is the basic formula, 2D sin theta is equal to m lambda. If you there are UG students, 2D sin theta is equal to m lambda, and that Bragg's law. And if theta is shifting to left, that means D has to increase, because 2D sin theta should remain as constant. So the product, if it has to remain constant, as theta increases, D is decreasing, or the vice versa. So here what we have observed is, as we introduce zinc dopant, the peak has shifted to the left. That means the lattice expansion has taken place. And this is the indication that some changes happened. One is introduction of zinc, because zinc has slightly higher atomic radii compared to copper. That is one reason. Another inference what we can draw from here is there may be interstitial defect that is formed. Because if the interstitial is entering into the system, there is no space for the interstitial atom. So obviously the cell has to expand. So cell expansion is clearly visible here. But of course, it will not confirm that it's due to oxygen interstitial. It will tell that the lattice expansion has happened. Then this is the ratio of the intensity that, okay, it will not tell about oxygen interstitial. Then crystallite size is normal. When we add dopant, it will reduce the grain growth. So the grain growth reduction will happen when you add the zinc as the dopant. This is the morphology. The morphology has shown significant change. From regular growth, it has shown some irregularity when the zinc is added, because the field will be uneven when you add some foreign impurities. And this confirms the spectroscopy, that energy dispersive spectroscopy. It confirms that the zinc has entered the system. The red shows what is the zinc to zinc plus copper ratio, and black shows what is the source that we have used. Of course, there is slight reduction compared to what we expected because of the high temperature process. Okay, this is a band. This is okay. This is what the confirmation for oxygen interstitial. So we have taken the photoluminescence. It is the study that we can, or that is the tool that we can use for the defect analysis, where we excite the system by some exciting wavelength, whose wavelength should be such that the energy is greater than band gap. So you are making the excitation to happen. Then during the de-excitation, it will come through various energy levels, and the intensity or the wavelength versus intensity, that will tell about the different energy states. And if you see here, there are various peaks, deconvoluted peaks, 565, 884. Then it's given there what are the peaks. So 565 is a copper vacancy. Then 884 is bandage emission. Then other peaks are from the defects. The peaks which are at the center, they are from the defects. That is, the blue one is due to oxygen interstitial, and the green is due to the oxygen vacancy. And if you see here, after incorporation of zinc, and that pink colored one, that is from zinc the zinc related emission. So if you see the graph, the intensity of the oxygen interstitial has increased compared to oxygen vacancy. So that confirms that oxygen, incorporation of oxygen into the lattice as interstitial. So oxygen is entering into that. That ratio will tell what is the fraction that has happened. And these are the defect levels from where the energy emission is happening. That is what, 676. So if you see there, 676 peak, its intensity increased soon after incorporation of zinc there. And we further confirmed the oxygen interstitial by X-ray photoelectron spectroscopy, where the oxygen interstitial related peak is having higher area compared to oxygen vacancy. That further confirms that our incorporation of zinc has successfully increased the fraction of oxygen interstitial, and the oxygen interstitial will create a shallow acceptor level just above the valence band, and that will enhance the p-type conductivity of the copper oxide. So our aim, the copper oxide is a p-type semiconductor, so we wanted to enhance the electrical property, as I mentioned. So it will form a acceptor, shallow acceptor level just above the valence band, and its density has increased. So we expect some higher carrier concentration there. So this, the right side slide, that is the perfect confirmation that the oxygen interstitial is having the role in deciding the carrier concentration. If you see the pattern by green and red, sorry, the black and red, they are following same pattern. Red is oxygen interstitial to oxygen vacancy ratio, and black is the carrier density. The carrier density is following that ratio. That means the interstitial will increase the carrier density. So that will reduce the electrical resistivity. So we have successfully incorporated oxygen interstitial in that, and we were able to demonstrate that the resistivity can be reduced by oxygen interstitial. The next work, what we are doing is a fabrication of solar cell based on that. Again, this is not the, I can't say that oxygen interstitial will perfectly help us in fabricating, because we are creating the defects here. So defect will lead to some scattering also. So when it comes to device performance, we may have to further tune the concentration of or the density of oxygen interstitial there. But this work will success. It says that oxygen interstitial will enhance the electrical conductivity of copper oxide. Okay, that's the summary of that work. And whatever I have presented here, they are the publications, and this is the recent publication. It is expected to come in the November issue, harnessing the intrinsic defect from isovalent dopant. Okay, this slide is prepared by my student, Ms. Aditya Prakash. I acknowledge her contribution. Thank you. So basically, like the defect, normally think that ideal emission is better, but we are introducing some deliberately some defects there, and we are trying to tune the property to that. And the only requirement here is you have to control that. So what fraction or what quantity you need. So how to control that? That is what the for getting efficiency, we were able to allocate around 10% conversion efficiency.
Thank you, sir, for your wonderful words. You have enlightened us with a great knowledge. Here we have come for a short tea break for 10 minutes. Now it is exactly 11 o'clock. 11:10, again we will gather here and we'll be acknowledging another keynote address, scientist from Iran. Okay, exactly 10 minutes. Time will be there as a tea break.
ಸ್ವಲ್ಪ ಆಚೆ ಮುಂದೆ ಇದು. Good morning, ladies and gentlemen. A pleasant and a grace-filled morning to each and every one of us. I, Dr. Anant Kumar Kulkarni, Professor and Head, Department of Mathematics, Srinivas Institute of Technology, Mangalore, and the convener of this two-day international conference on recent research in applied sciences, ICRRAS-2023. The task of introducing our keynote speaker in this two-day international conference is indeed a great privilege to me. I know it is not so easy job, but the thought that he is a man of virtue of simplicity, I feel elated to introduce Dr. Reza Sharfuddini on this momentous event. After all, he is a living inspiration to all of us. I personally welcome you, sir. Dr. Reza Sharfuddini, born on 9th April 1981, and he is a citizen of Iran. He completed his bachelor's degree from an institute, Persian Gulf University, PGU, Bushehr, Iran, from in the year 1999 to 2003. And he completed his master's from Institute of Advanced Studies in Basic Sciences from Zanjan, Iran, in the year 2004 to 2006, and he completed his doctorate, PhD in mathematics from Busan National University, Busan, South Korea, in the year 2010. Presently, he is working as an associate professor in the Department of Mathematics of Persian Gulf University since January 2022. Apart from his regular duties, he is a representative of Iranian Mathematical Society at Persian Gulf University since 2019. He is a member of Scientific Executive Committee of Maths, House of Bushehr. He is a visiting professor, Busan National University, from 1st December to 10th December 2017 of South Korea. He was a visiting professor of Busan National University in the year 2013 of South Korea, and he is assistant professor of Persian Gulf University since March 2010 to January 2022. Brain Korea BK21, he is an awardee of Brain Korea BK21, and he is a member of American Mathematical Society, and he is also a member of Korean Mathematical Society in the year 2009 to 2011. He was a member of Iranian Mathematical University since September 2001. And today's speaker is a very active researcher. Some of his interested in the research areas are as follows: that is data science, graph mining, fraud detection, algebraic combinatorics, coherent configurations, generalized group theory, mathematical chemistry, chemical graph theory, and sir is very much interested in learning new things and new applications of mathematics, especially algebra and combinatorics. He also interested in algebra and discrete mathematics and their applications to data science, chemistry, physics, biology, and computer sciences. He is having 20 publications in national and international journals in his credit, and 23 research papers he has presented in national and international conferences, and he has attended 20 international conferences. Apart from this, his honorary activities are, if I go on telling this, the list is so lengthy, it takes lot of time. So some of the highlights of his honorary activities are like this. He is selected to get BK21 scholarship, Busan National University, PNU, in the year 2007 and 2011. He selected for diploma, has been selected for a diploma program at ICTP Italy 2007. He was a first rank student in BSc, that is in the year 2004, of Persian Gulf University, Bushehr, Iran. He is also helping in organizing international conferences, mainly, and he is actively taking part in that. Some of the conferences he arranged in his leadership, his role is as an executive manager of 27th Iranian Algebra Seminar, February 9th and 10th of Persian Gulf University, Bushehr, Iran, International Affairs Secretary of 6th Conference and Workshop of Mathematical Chemistry, Persian Gulf University, Bushehr, February 2013. He was an organizer of the Scientific and Administrative Committees of 6th Conference Workshop and Mathematical Chemistry, Persian Gulf University, Bushehr, in the year 2013. Apart from his research, he is guiding MSc students as well as PhD students. So with this, ladies and gentlemen, I am very much excited to introduce such an eminent person, Dr. Reza Shafruddini, to this two-day national conference. Sir, I personally welcome you to this conference, and I would like to take I'm requesting you to take the dais. Please, sir. It is over to you, sir. Thank you.